Okay, sir. Hello,
Okay.
everyone. I'm Shriram Kulkarni, mechanical finance.
Hello. Shriram, you may start. I think so. You may share the screen once again, please. Hello, Shriram. Can you share your screen, please?
I think he's using two devices, phone for the video and laptop for possibly for the presentation. Laptop
Yes, I
doesn't have the
believe so.
camera. That's what I see here.
He's trying to join from a different device, I see. Shriram, am I audible?
Yes, sir. You are.
Yeah, you can share the screen and start with the presentation. We have stopped the timer, so please start.
Okay.
Shriram, you can go ahead.
So, is the screen visible?
Yeah, screen is visible. You can go into full screen.
Okay.
Yeah.
My topic is automatic electric vehicle charging system. What is the main problems in electric vehicle charging system? We are dealing with the issues of electrical charging system. As we know, charging systems are not everywhere, and current charging systems are not fully automatic, and these are we have to plug in and unplug every time. It takes more time to charge. And charging systems are not flexible, but as like the bus charging system is not compatible with the car charging system, and two-wheeler charging system not compatible with the truck charging system, like that. And all charging systems are not compatible with others. Example, a Tata charging system is not compatible with the Hyundai charging system. Hyundai charging system is not compatible with the other charging system. And to procure all these different charging system, it will costlier. And we did a survey. According to the survey, one charging system will cost 40 lakh to 50 lakh, including the land. Because of it, it can only charge maximum 2 to 3 vehicles only at a time. Now, how can make it faster? How to make a payment? How to track it? How to measure the charging status? We innovated and we introduced the automatic electric vehicle charging system. It is a fully automatic charging system. As we know, the future belongs to the electric vehicles, and the electric vehicles are growing, transferring to the autonomous to the fully automatic device, fully automatic electric vehicles. But the charging infra is not developing according to it. Because of that, we presented the automatic electric vehicle charging system. As its name indicates, we need not to plug in and plug every time. The vehicle comes and park in the charging stations, and the table sensor will sense the vehicle, and the table lifting mechanism will contact with the surface of the car. The vehicle will start charging. Because of the conduction and parallel connection, we can charge any type of vehicles at the same time, and it is compatible with the any type of vehicles. Means we can charge bus, car, auto, truck at the same time. And with the help of NFC, it will contact with the car, and it will exchange the data of the car to the system. NFC is a near field communication device. It is used for the mainly transferring the data. This is the block diagram and circuit diagram how the exactly mechanism of the vehicle charging system will work. The electricity will come from the grid, and the AC to DC converter which will convert the electricity, and with the help of the input data of the sensor, it will send the data to the table lifting mechanism. And after analyzing the data and understanding it, and table lifting mechanism will go and contact with the surface of the car, the vehicle will start charging, battery will start charging. And you can see the flow chart. This is the how exactly sensor data will works. First, sensor will start and initialize the system, and collect the data, analyzes it, And once it will sense the presence of the car, it will break the loop and it will supply the electricity to the table lifting mechanism. Table lifting mechanism will lift and start charging. Vehicle will start charging. This is the prototype of the electric vehicle charging system. The vehicle will come and stop in the parking station, and table lifting mechanism lifted, and it is charging the car. And here you can see the green light. This is the indication of the charging station. This is the output of the charger. This is the result of the charging system. We tested the one car at a time, and we charge the multiple car at a time. We can we here we charge the more than two vehicles at a time, and we got the 100% efficiency. And what is our current status in the electric vehicle charging system project? We built the crude prototype with the 100% result, and we have checked for the prior check of the patent by the KCST. Now we are applying for the patent, and we present in IEEE, won the first president. We are now collaborating with the real-time prototype for the IIT Dharwad. We are under talk with the startups and the EV companies to working prototype testing purpose. What is the social impact? What can be? How can it be helpful to society? It is a fully automatic device. We need not to pay any barcode scanning or physically payment like that. It is a fully automatic device. Need not to pay anything. It will directly deduct the amount from your credit due. It will create a due in an application, or it will directly deduct amount from your bank account. It reduces machine cost by 50%. It can be made 100% end-to-end eco-friendly. Once the charging system is now compatible with any type of charging system, one charging system can charge more than 100 vehicles at the same time. It prevents e-waste generation. It is a sustainable product, and it is for both for domestic and international market, because they need not to change that major system in it. It is universal system. We can charge any type of vehicles at the same time. And where can we implement it? It can be implemented in railway stations, school and college parking, office parking, hotel parking, and car parking, everywhere. We can also implement in public transport, commercials, and private vehicles also. These are some advantages. It is faster, need not to plug every time. There are no accident. It is fully automatic. It increases efficiency and the revenue at the same time. It reduces pollution. We can make it end-to-end eco-friendly. Thank you, everyone. If you have any questions, you may ask now.
We may start with the questions now.
Yeah.
Juras.
Shriram, I mean, what it comes across is that what you are saying is that all with the existing charging system, there are compatibility issues because different manufacturers use different charging connectors. And
Yes.
as a result, you are saying that let's remove all those compatibility issues and just have one type of connector for everything, so that
Yes, sir.
that problem is removed. That fundamentally, that is what you are trying to say here.
Yes, sir.
So why is it not there? I mean, it's not as if this particular problem is not visible at the policy level or anywhere. Why do you think it is not there? Do you have any understanding of the challenges which will come if you try to, let us say, do a high? I mean, you have done this work in the lab only at the 5 volt level. Okay, if you do this similar kind of thing in the field on a battery at, let us say, with 60 kilowatt charger. Okay,
Yes, sir.
where which is carrying a very high amount of current. Do you think that there will not be the serious technical challenges with this, what you have said, and this is not going to really work?
So we have done the crude prototype testing. We got the 100%. If we go for the real time, it's 60 kilowatt to 100 kilowatt. We may get the 2 to 3% error, but we can achieve more than 95%.
I'm not talking about the efficiency there at all. I'm talking about the other issues which will come when you try to. Have you handled a system where you are handling, let's say, contacts, and you are running 30 ampere current into that or 50 ampere current into that? Then you're talking of 60 kilowatt. We are talking of a much higher level of current there as well. Okay,
Yes,
in 3.3 kVA level, we are talking about 15 ampere current. In a 3.3. Okay, when we go to 33, we are talking about 150 ampere. We go to
Yes,
60, we are talking about almost 300 ampere current. Okay, so do you have any idea what it takes to run the 300 amperes of current through a cable or through a contact system and then to make sure that you don't run into the technical challenges there?
Yes, sir. Because of the we are using the high gauge conduction plates, copper plates, and we are using the hyper wires. Because of that, we are using the direct current. There is not that much of issues.
Sriram,
Yes,
sorry
ma'am.
to interrupt. I think what Sudhanshu sir here wants to indicate is what about accidents? You know, when there is an open area transmitting such a high electricity, how will you look at possible cases of accidents which might be there? That is the first question. And second, the battery location would be different in different vehicles.
Yes, ma'am.
How will you cater to that?
Ma'am, first of all, the charging system is not active every time. The charging system active when the vehicle comes and stops. After the contact between exchanging the data between vehicle and the charging system. After that, it will send the power supply. This is the main safety mechanism, and other than it, there is no need of any battery placement like that. We only attach the one conduction plate below the surface of the car. After the sensing the data and the just stable lifting mechanism touches the conduction plate, vehicle will start charging.
Okay, maybe you need to think through a little, because even with the table lifting mechanism that is there, the positioning of the battery for a car would be different from that of a bus, would be different from that of a truck. So every time the contact might not happen. And again,
Yes, ma'am.
integration of that wireless again would be a huge expense to the vehicle owners.
Yes, ma'am. We go into
So
this.
you need to think on that, think a little bit, and then maybe you can write back to us or drop a message, and then I think all of us would be happy to guide you on the same.
Yeah, talk to those who are doing this in the real life and then see as to how much acceptance they indicate of this idea. Because honestly, I mean, either it is something what you're talking saying that something very simple, which nobody has thought up of, and then it should be a great solution, or it is something because everybody, I mean, it's not going to work. That is why nobody's really using it.
So
See, it is
currently
like
people are working on it,
having.
but they are working on induction mechanism, not on conduction mechanism. But induction mechanism, it is harmful for the environment, all the animals also, and it is the efficiency drop of 80%.
I agree. That is
It,
why this kind of charging is used for mobile phones only. The
Yes,
induction
sir.
kind
Yes,
of
sir.
thing. It cannot be used for your high current charging.
Yes, sir.
It
yeah,
can
it's
only
like
be used when
having a
you're.
live wire. It's like a live wire.
Yes,
Okay.
it's like a live wire open, open,
You can
and then talking
surely,
about 100 amperes of current. That is huge. A very very high amount
Yes,
of
sir.
current there.
and it requires very specific kind of handling.
Yeah.
Even if you handle it well, still there'll be accidents. So I
Doing in the
think
lab
you
at 5
should.
volt is one story, but then when
Yeah,
you talk about that, it's a
I,
totally different
I
story
think the
there.
right person for you to speak with is Satish, because he is actually from tomorrow going to do this only full time. So maybe you should speak with him and understand what can go wrong here.
Yes, sir. We are working currently. We are working on real-time prototype with the collaboration with the IIT Dharwad. After that, we will see.
Sriram, I think just to put some boundaries to it, one, it sounds very exciting. If it
Yes,
is
sir.
if it is real, I think there are a lot of questions. Is it real? Is it accident prone? Can we make it safer? And why nobody has thought about it, or somebody has thought about it and rejected it already? Then it's good to know why it was rejected.
Yeah.
So that is number one. Number two, if it is becomes, let's say, very difficult to even have high current vehicles or high voltage vehicle needs, even if it solves small voltage vehicle or let's say low current vehicle needs, that itself can be a huge market. So long it is workable. Let's say if you are able to just solve it for e-scooters, if you are able to solve it for e-rickshaws, that is a big market if you are really able to solve it in a sustainable and safe manner. So just try to focus on even small ideas first. And if it is doable, I would love to stay in touch with you somehow. I will get in touch with you via Aegis team. And once you are done with your prototyping and others, let's at least exchange notes. We'll be more than happy to work with you.
Yes.
So,
So that's what I
as
thought, that either it is something which nobody has thought because it is too simple, so and it's not going to work, or is it something that it is not going to work. That is why nobody is really getting into that.
Yes, sir. Currently, we are contact with the Tata passenger electric vehicles. We want to the test with the Tata Nexon vehicles for the charging it, and
Okay.
we are currently working on it.
Very
Okay.
good. But Sriram really loved it. If you are really able to solve this problem, this is a big problem, and it's a huge market. If you are able to
Yes, sir.
really
Yes.
solve it nicely.
You have to keep in mind all those safety requirements which are there. So there are those certification requirements of ARAI.
Yeah.
When you are working
Yes,
with IIT Dharwad, keep this also in mind that whether this kind of solution, the design that you are talking about, will it be able to meet those kind of requirements?
Yes, sir.
Any more questions from the viewers?
No.
Very interesting. Keep doing the good work, and as guided by the veterans, please stay in touch with them and keep doing it. Thank you.
Uh, Thank you so much, Sriram, for your presentation. We would be admitting the next presenter now. So